From the word gina. Thermal expansion. Change in temperature of a body causes change in its dimensions. Thus, increase in the dimensions, i.e., length, breadth and thickness, of a body due to increase in its temperature, is called thermal expansion. Thermal expansion of solids. All the solids expand on heating. This expansion of solids is called thermal expansion of solids. Thermal expansion of solids are of three types. Linear expansion. When expansion of solids takes place along a line as in the case of thin rod, then the expansion is called linear expansion. Coefficient of linear expansion, alpha, equals increase in length, initial length x rise in temperature. Alpha equals increment L, lux increment T. Its unit is per degree C. Superficial expansion. When expansion of solids takes place in two dimensions, as in the case of a lamina, both length and breadth increase. It is called superficial expansion. Coefficient of superficial expansion, beta, equals increase in area, initial area times rise in temperature. Beta equals increment A, x increment T. Its unit is per degree C. Volume expansion or cubical expansion. When expansion of solids takes place in three dimensions, as in the case of a cube, length, breadth and height all increase. It is called volume expansion. Coefficient of volume expansion, gamma, equals increase in volume, initial volume x rise in temperature. Gamma equals increment V, Vx increment T. Its unit is per degree C. Relation between alpha, beta and gamma. Beta equals 2 alpha, gamma equals 3 alpha, also alpha, beta. Gamma equals 1, 2, 3. Thermal expansion of liquids. Liquids have only cubical expansion because they have no shape and size. When liquids are heated, then the vessel in which liquid is kept also heated. So, first vessel expands and then liquid. Thermal expansion of liquids are of two types. 1. Apparent expansion. The expansion of liquids neglecting expansion of vessel is called apparent expansion. Apparent expansion coefficient. Gamma A equals apparent increase in volume, initial volume x rise in temperature. Equals increment V, V times increment T. 2. Real expansion. It is the actual increase in volume of liquid. Real expansion coefficient. Gamma R equals real expansion in volume, initial volume times rise in temperature. Equals increment VR, Vx increment T. Relation between gamma A and gamma R. Gamma R equals gamma A plus gamma G, where gamma R equals real expansion of liquid. Gamma A equals apparent expansion of liquid. Gamma G equals volume expansion coefficient of material vessel. Anomalous, exceptional behavior of water is the temperature of water increases from 0 to 4 degrees C, the density of water increases, and as temperature increases beyond 4 degrees C, the density decreases. The variation in the density in the water with temperature is shown in the figure below. Thermal expansion of gases. In expansion of gases, there are two coefficients. Volume coefficient, gamma V. The change in volume of gas per unit volume per unit degree Celsius at constant pressure is known as coefficient of volume expansion. Pressure coefficient, gamma P. The change in pressure of gas per unit degree Celsius at constant volume is known as pressure coefficients. If the temperature and pressure of gas is constant, P1, P2 equals M1, M2, where P1 and P2 are pressure of gas. If same volume jar having P1 and P2, pressure and T1 and T2 temperature, then P equals P1 T2 plus P2 T1, T1 plus T2. After joining both jar,